This is the Introduction to Advanced Algebra 2. I'm Mr. Stark. We're on topic 1, which is titled Real Numbers. This is lesson 1B, called the Basic Properties of Algebra. You can follow along using this document, which includes space to take notes on the properties, integer exponents, as well as scientific notation. So let's get started. What are the properties of real numbers? I'm so glad you asked. Let's talk about them. There are 5. First, their names. Number 1, commutative. Number 2, associative. Number 3, identity. 4, inverse. And 5, distributive. I hope these properties are familiar to you. If not, it's quite all right. We'll be going through each one. As I go through each one, I'll be using letters that represent real numbers. And the letters that I'll be using are U and V and W. So we'll practice writing our U's, V's, and W's. There are 2 parts to the commutative property. First, addition, then multiplication. The addition property says U plus V is equal to V plus U. And the multiplication property says that U times V is the same, equal to V times U. You could think of the U's and V's commuting left and right. The associative property has 2 parts as well, addition and multiplication. The addition one says the quantity U plus V plus W is equal to U plus the quantity V plus W. The multiplication property says quantity U times V times W is equal to U times the quantity V times W. In this property, you could think of the letters or numbers associating with different groups, just like we would in society. The identity property has 2 parts, addition and multiplication. For addition, we have U plus 0 is equal to U. You know, if you add nothing to U, you still get U, right? Same with me. For multiplication, we have U times 1 is equal to U. For example, if you multiply your money times 1, you still have just your money. Shucks. And the inverse property also has 2 parts, addition and multiplication. For addition, we have U plus negative U is equal to 0. As far as addition is concerned, negative U is the inverse of U. And for multiplication, we have U times 1 over U is equal to 1. What that means is 1 over U is the inverse of U. But be careful. In math, we usually say 1 over U is the reciprocal of U, because when we talk about functions, inverse means a different thing. For the final property, the distributive property, we have 6 lines of information we'll add here. The first 3 relate to multiplication over addition, and we have U times the quantity V plus W is equal to UV plus UW. We also have quantity U plus V times W is equal to UW plus VW. Don't forget, U, V, and W represent real numbers. So if they were just numbers, we would usually add the numbers inside the parentheses first, then multiply them by the number outside of the parentheses. The last 3 lines relate to multiplication over subtraction. So very similar to what I just mentioned. U times quantity V minus W is equal to UV minus UW. And the final one, thanks for sticking with me, quantity U minus V times W is equal to UW minus VW. It's funny how those letters together make me think about different things like UV, ultraviolet, UW, University of Wisconsin, VW, Volkswagen. I thought we could sneak in one little example here. We have quantity X plus 3Y times X. So we'll apply the distributive property and distribute the X to the 2 terms inside the parentheses. So we get X squared plus 3XY. Now let's talk about integer exponents. And what that means is we're raising a variable to an integer, like 2 or -3 or even 0. First things first, if we raise a to the n power, or I could say x to the n power, that's a shorthand notation for writing a times a times a times a until we get n a's written down. It doesn't mean we multiply a by itself n times. It just means there are n factors of a. So a to the third power is a times a times a. Notice there's 3 terms, but there's only 2 multiplication symbols, or dots. N is officially called the exponent, and a is called the base. Now, for the main event, I want to introduce you to a mad scientist who works only in the PM hours. He was so mad, he started multiplying bases with exponents. He did so in a special scientific supply called a beaker. And what he realized, when you multiply bases with exponents, you must add the exponents. Then he continued his research, but only in the PM hours, so nobody realized how nerdy he was. He started dividing bases with exponents using beakers and test tubes. And there was probably something being distilled because that sounds like a neat vocab word. What he realized when he divided bases with exponents was that you must subtract the exponents. Finally, he started going bonkers in the PM hours. This is what he did. I'll tell you what he did. He raised bases with a power to a power. And you know what he did it in? A beaker. His experiments led him to the idea that when you raise bases with a power to a power, you must multiply the exponents. He was a mad scientist. I tell you, so mad, but only in the PM with a beaker. Oh man, I'm always amazed at what that mad scientist can do. Imagine if he could work during the day, how much stuff he could get done. Well, we might as well get some more done. Let's apply that MA part of the mnemonic using this example, 5 to the third power times 5 to the fourth power. Applying the rule, we have 5 raised to the 3 plus 4, which is 7, and that's our answer. Of course, we could find out what that is on a calculator or by hand. Let's do another example for the DS part of the mnemonic. We have x to the 9th divided by x to the 4th. Notice how I used a variable there instead of the number. So what that is equal to is x raised to the 9 minus 4, which is 5. So we have x times x times x times x times x. And for the PM part of the mnemonic, we have something like y squared raised to the third power. So that's equal to y raised to the 2 times 3, which is y to the 6th power. Here are some other properties that are helpful to know. The first one is x to the 0 is equal to 1. This works for all real numbers except for 0. 0 to the 0 is a controversy. Because is it 0 or is it 1? Then we have x to the negative 2. This is a specific example. That's equal to 1 over x squared. So if we have x raised to a negative exponent, we could rewrite that as 1 over x raised to a positive exponent. And finally, we have these two properties that are basically an application of the distributive property for exponents. Scientific notation is the last thing we'll cover here, and we'll do that in these 3 ways. First, the standard form, and then how to convert in each direction. So the standard form is c times 10 to the m. And that c value is a number in between 1 and 10, exclusive of 10. So c can be 1, but c cannot be 10. And m is simply an integer. For our first example, we'll convert from decimal to scientific notation. So the decimal is 0.0000345. To convert that number, we'll count how many decimal places it takes to get to a number in between 1 and 10. So follow along. 1, 2, 3, 4, 5. And we have something in between 1 and 10, which is 3. That means we have 3.45 times 10 to the, not sure if it's 5 or negative 5. But notice that if 10 was raised to the 5th power, that'd be a really large number, but we're looking at a really small number. So it's 3.45 times 10 to the negative 5. The second example is converting scientific notation to decimal. So we have 1.23 times 10 to the 5th power. We need to move that decimal point 5 places. And we're going to move that to the right because 10 to the 5th is making 1.23 get bigger. So 1, 2, 3, 4, 5, and we have 123,000. That is the end of Lesson 1B, Basic Properties of Algebra. Thank you so much for watching. Be sure to check the description for more info and add a comment. Thanks a bunch.